Hi, welcome to In-Depth Tutorials. My name is Salman Aziz. I've been doing programming for more than 10 years and I decided to make some video tutorial series in which I'll go in depth about certain topics and I'll go from beginner level to advanced level. Let's start. So this is a two-part series. In part 1 we're going to discuss RxJS observables. In part 2, stay tuned for RxJS schedulers. We're going to go deep dive and we're going to answer what the execution context of observables are. Are they async or they async? We're going to answer all those questions. But let's begin with this part 1, RxJS observables. In this, we're going to discuss about hot observables versus cold observables. We're going to discuss subjects, what RxJS subjects are, and we're going to take a journey in which we'll start with the events and then we're going to go to promises and then I'm gonna explain about observables. I think that'll give you the clearer picture what observables actually are. I was searching online for a good definition of observable and I came across Ben Lash article in which he describes observable are function that tie an observer to a producer. Now, even if you don't understand anything, the only thing you need to understand, and it's some sort of a tying mechanism between observer and a producer, and functions are used for that. What observer is, if you don't know about it, it's just something like a listener in events world, if you know, and producer is where things get produced, where basically you can say task execution part. It's the task execution part. Now we're going to use this definition and apply it on events. So now let's dive deep into events. JavaScript events. If you have used JavaScript events, you must be aware about this syntax that we have window add listener and we call it, and once it's executed, event is invoked and console log all resource finished loading is called. Now let's see that in the context of the definition that we have just learned. So we have producer and we have observer who listens to it. Over here, the producer, you can say it's a window object because it's the window object. The first step that happens is that it says I have a function called add event listener and it says I'll accept a string and a function into it. So the step 1, it defines and passes that add event listener, and it's basically has first as a string input. The second is basically the function over here. The observer uses it and says, here you go, I want to use load, and the function which I'm passing is nothing, just a function that will console logs it. In the second step, it gives those things details to the producer. What happens is when the DOM loads, it goes through all the listeners. So whatever the listener list is, it can be one, it can be many, and it just call those functions. And once it's called, the event is invoked as a third step. As you can see, the function is passed from observer over here to producer. Once the function is passed from observer to producer, it is invoked. Now this is the mechanism that we are using is called push based mechanism. The push, why it's push? Because the observer is pushing the function, to the producer. That's why it's a push based mechanism. Whereas if we think of a pull based mechanism, it's normal JavaScript. In normal JavaScript, what happens is we say R is result, do some processing, and once that processing is done, console log it. So this is pull based mechanism. We are pulling the value from here to here, whereas in push mechanism, what happens is the function gets passed and it's a decoupled architecture. So observer just gives the function and say you do whatever you want to. Whenever you have the DOM loaded, just call me, and this is what it does, it calls it. All of this is possible because of the concept, the function passing concept, which is, you can see, JavaScript closures. The JavaScript closures, like variable you can pass in JavaScript to a function, you can actually pass a function to it also. And that function is not only passed, it maintains the scope of it. So for example, if you have a variable out of it, and that variable is 0, you can pass that and add it over here, and JavaScript will maintain all those scope references. Whatever this function is using, it will maintain those scopes as well. Now that is really cool, but there is two problems over here. There is no mechanism. Once the error happens at DOM load, it cannot inform, it just have one function, so it cannot say to the observer that some error happened. So there is no mechanism for error. This is there is no mechanism for defining an error. Producer cannot inform the observer about the error. The second part is the completion part. Now what happens is, once it's get completed, there is no way to tell that this is done. The producer is done now, the DOM is loaded, there will be no further events, but there is no way to communicate that knowledge. So these are the two problems. Now let's see how the promises tackle this problem. Now let's see how the producer and observer concept applies to JavaScript promises. If you have ever used JavaScript promises, this is how they work. We create the promise like this, and then we're gonna use it, the promise, the consumer uses it like this. So if we can name it, this is the producer part of it, and this is the consumer part of it, which is our observer part of it. So we can show it in a form of diagram. This is the producer and this is the observer. Now over here, the promise producer is wrapped around an object called a promise, right? It's wrapped around an object called a promise. Now it takes two functions. The producer is wrapped around the promise, and it takes two more functions as an input parameter. This is resolve and reject. So this is the function 1, and this is the function, another function, it takes an input. And once it's get done and it's get completed, it calls resolve and reject. Simple. Now how it works at the observer level is basically, this is the first step. As we can see that this is the first step. It defines a wrap around a promise, but what important thing is, it takes two more functions, not one function as we see in event. Over here it takes two functions, resolve and reject. Now once this is passed, observer then define those functions. Where they are defined, it is defined over here. It's very simple, just console log. In error case, just console log. In this case, it defines those functions and gives those functions to producer. It basically gives those two functions to producer. Now it's producer. It do some processing over here, as you can see, do something over here, and once it's get done, the resolve and reject are called. And once the resolve and reject call, it's basically invokes the same functions over here and this one over here. And this way the observer is notified about something has been completed or some error happened. As we can see, this solves both of the problem. We saw it at the time of events. For example, there is once the error occur, this reject is called, and once the completion is done, the resolve is called. So it solves all those two problems, but there is still a little bit a problem. Still, there is no mechanism for continuously emitting. That's another thing which we can see, that there is no, if we want to continuously emit, there is no mechanism, because if you see it over here, once resolved is called, it's done. At this point, it's done. There is no more further action. It's completely finished and the promise is done. So there is no way of continuously emit values. Now if we have a bit and more understanding, is it a push or is it a pull? It's quite easy to say it's a push based mechanism. As you can see, there are two functions passed. Producer defines those two functions wrapped around a promise object, and the observer sends those two functions in the then statement, and once the then statement is called, it invokes it, and the third step is basically it executes and it notify it over here in the third step. So this is how the promises work. Now let's discuss the real topic, RxJS observable. It's important to note over here that observable is a design pattern, and it's really well defined in Gang of Four book, where it describes the observable pattern in details. I highly recommend to go through that book as well. What we are seeing here is RxJS implementation of observable, and how the code is working. Let's see that. This is the part of producer. This is where the producer is defined. Now let's see what producer is doing. It's wrapping around observable. Like previously we were wrapped around promise, now we are wrapped around observables. Over here there is an input it's expecting. This is the syntax, which it means that its input is expecting a subscriber. What subscriber should be? It should be an object which have three functions defined inside it. What three functions? Next, completed, and the third one is not mentioned over here, but it's error. So once an object which contains three functions, you can pass to it, and what the producer will do, it will say, I will do some processing, like it's emitting 1, it's emitting 2, it's emitting 3, and it's emitting after set timeout, it's emitting 4, and then completing it out. Now let's see at the observer level how things are working. This is the observer part of it. What happens at the observer part of it, you can see it's giving an object which three functions are defined on it. So now here it gives three functions. Like previously it used to give two functions, now it's giving three functions, but it's also giving in the form of an object. So it's an object, as you can see, it's start and ending, but it has three functions defined on it, and these three functions right now are doing nothing but console log. Once next is happened, got value, when something wrong happened, and this gets executed over here. So if you can see in the form of diagram, we have the producer and we have the observer. The first thing, give me an object which has three functions defined. What three functions? Next, complete, and error. Once you define them, I'll do my processing whatever I want to. Right now it's 1, 2, 3 emitting. In real case it will be some processing involved. It processes those things and calls those functions. At observer level, what observer do, it's similar to what we discussed in the promise. It gives those functions. It gives those functions in the form of object. As you can see it over here, it's giving those functions in the form of object over here. And once it's given to it, what happens, actually now it's completely decoupled. Now the the producer is in charge. It does the processing over here, and once the processing is done, it notifies it, but it has the power of notifying all three things. So it solves the problem of error. How it solves the problem? Because it has the object. Once the error happened, it can call the error over here, like error, the same subscriber.error it can call, and once the error will be called, this will be invoked, so the error situation is solved. Once the complete is called, this will be called, the observer will be notified about the completion also, and when the next is called, it will call the next, and this is where the continuous emission will occur. That's why we observers are called, this is a stream of events. This is what the stream of events is actually, that each next call is a stream. It's like, now in the form of marble diagrams, you can see that it's emitting first 1, then emitting 2, then emitting 3, then emitting after set timeout 4. And how it's emitting, you can see that it's the marble diagram, and this is the point we say it's completed, because after emission of 4, you can see that how it's working. This first 1 is emitted, it calls 1, 2 is emitted, it's called 2, the 3 is emitted, it's called 3, and once 4 is emitted after set timeout, it calls this one, and it calls complete, and this arrow is indicated by the complete over here. This is how we read the marble diagram as well. As you can see, it's quite similar to promises, but it is internally quite different as well. Basically, promises are kind of, it's defined by ECMAScript. It's built into JavaScript, and it's asynchronous in nature. And why it's asynchronous in nature? It's because it's a micro task. I'm gonna dive deep into these topics once I'm discussing about RxJS scheduler, what micro task is, what macro task is. But just keep in mind that the promise object which is wrapped around is actually something in JavaScript. Over here, once we see about the observer object, it's not completely part of ECMAScript. Although there is a proposal for that, but right now currently it's just a class containing inside it. Now if I ask you, is it a push-based mechanism or is it a pull-based mechanism? I think it's quite clear that it's a push-based mechanism. Over here it's quite similar to promise, but it's passing three functions, which solves the problem, the last one we discussed, that continuously emission is not possible. That's why we call observable is in the form of stream of data. It's not one time like promises. It continuously can emit, and once it's complete, then it's get done. Now let's go back to the definition we earlier discussed. Observables are functions that tie an observer to a producer. Now what it's saying is that It's a mechanism through which an observer sends functions to producer, and the producer then invoke those functions. And I think that makes things a bit more clearer. Now let's discuss hot observables and cold observables and why it's really important to understand this concept. I was trying to find a good definition of observable. I came across Ben Lash article which cleanly defines what cold observable and what hot observables are. So now let's see. A cold is when observable creates producer. If you don't understand anything, just remember that it's when you call new observable, most of the time it's a cold observable. Why it's cold? Now let's see the example we earlier discussed. Is it cold or hot? It's cold. Why it's cold? As we discussed, whenever you're doing new observable kind of thing, you're mostly cold. How? When we call subscribe over here, this is the execution part of it. At this point, this gets invoked, and the processing over here, all the processing gets it started over here. So the starting point of execution, this is the starting point of execution. This is really important. The producer starts executing. This is the producer part of it, and the producer starts executing at the point of subscribe. Now back again. Why it's useful to understand it. Now let's see an example. We have a producer which makes a database call, and we have a multiple observer. If we using cold observable, and that's what exactly happens when you use Angular HTTP clients, that's why we get complaints that it's making multiple calls. Why? It's basically when the observer calls the producer, subscribe happens over here, and once subscribe happen, it calls and gets the results, but it does this processing part of it. This processing, heavy lifting processing part of it is executed for each observer. So when this is called, it's called over here and it's returned. This is called over here and it gets returned. So it's this part is called 3 times over here. What actually we wanted is basically when observer calls a producer, it calls 1 time. So for example, we have observer. What actually we want is this calls, but it processes only 1 time and returns all those values over here to each observer. And this is achievable through hot observable. Now let's see what the definition of hot observable is. The same article described hot observable are observables closes over producer. Now there are different ways to make an cold observable hot, and the way you can use is different operators. And I'll go deep into once I'm discussing the operators topic, but right now you can think like you can use a share one. What it does, it makes it hot, so it's reusable. The execution part is shared, so you don't worry about like it's processing multiple times. Producer is doing multiple operation multiple times. Then we have publish, and we have a publish replay as well. We can use these operators to make a cold observable hot and gains the benefit to avoid extra processing. There is another way of making a hot observable. It's called subjects. It's a special type of observable, and let's discuss it now. Now let's discuss RxJS subjects. The content you see below is basically copy pasted from RxJS docs. The first paragraph, it's saying every subject is an observable. So basically, if you go even to the source code of subjects and you open the subject TypeScript file, you will see it's inheriting from observable. So this is really important, that it's nothing new. It is an observable with some special things inside it. Now let's proceed further. The paragraph, the whole paragraph, what it's explaining is that being an observer, you don't know. It is coming from hot or is it coming from cold? It just comes as a stream of observable. So being an observer, it does not know it's coming from hot or is it coming from cold. Now this is an important line. When we call subscribe, it does not invoke new execution. Previously we have seen in cold observable, once we call subscribe, that invokes the new execution. In subject case or in hot observable case, that does not happen. What happens then? It registers in a list of observers. And something similar to add listener. So we can go back to our first events one and add listener. The similar behavior happens over here. So if I can show you in the form of diagram, we have producer and it has the heavy operation it performs. We have observer, observer, observer. So what happens is once it's called this subscribe, 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 it does not do anything. It just register, register, register. When the heavy operation is performed over here, it goes through this list, enumerate this list, and then invoke each observer. And this is the way we avoid extra calculation. This is how it's hot. In the third paragraph, it's saying every subject is an observer also. Why? Because it's inheriting these three special methods onto it: next, error, and complete. And why it's useful is because now the producer is in charge. When it calls the next, when it calls error, when it's called complete, at this point the observer will be notified about it. And this is how events work actually. Now let's see an example. We create a subject, which is the producer. Then we have one observer and second observer. This is observer 1 and this is observer 2. What happens, what the producer does, because it's a subject, it has a special method called next. It calls this next and it calls it next with 1. It calls, the producer calls with 1. Producer over here calls it with 2. Now what eventually happens is basically once this P1 is called, it gets, because it's just registered in the list, it gets invoked over here. Once this is called, the same thing happen. It gets invoked from 2, second observer, and the first observer get invoked. And that's what the results also show. If you see these results, this is the exact same reflection.